TU Kaiserslautern right now as a postdoc, and Dr. Fazel is his colleague. The two of them they have done some excellent work in rhino grasshopper trenches, and the session that we have right now is on adaptive facade. Basically, it's on climate-based dynamic facades. And so,
I start this presentation by like giving you a kind of the story of my journey from Iran, and in 2015 when I came to Germany for the first time. So it was part of a network in Transsolar, if you have heard of this company, who gives some climatic concepts to the architects. And the idea is to maximize the impact of sustainable building design and deliver justice to the impacted people. So most of the people, for example, in Africa, in Iran, or in India, or in China, as you see in the map, they are more impacted by the climatic change, and they can make a big influence in the future of the planet. Thanks to digital parametric tools, we are very overwhelmed about the complexity of the surfaces and geometries, and we are kind of obsessed about the digital complexity, but the real complexity is somewhere else. We need this computational power maybe to evaluate alternatives and not to generate tons of them and then getting lost into the finding the best solution. So basically I start, after this long introduction, I start the main part of the presentation, part one, about the background and the concept behind the climatic conscious design and how we should care about climate in process of design or controlling a building. So I know that many of you are super familiar with this concept, so I try to keep it fast and short, and hopefully I can go until to the end. So yeah, this is a very very common quote in architecture: form follows function, forms follows performance. If you look to the architecture or the history of vernacular architecture, not only in Iran, but in India, in many countries, after thousands of years, they have found how to deal with the harsh climate to provide functionality or to provide the better performance in their buildings. So maybe this term sounds a little, yeah, the process is like that, looking to the shape of the buildings, even in this case, the facade of the building, how we should populate the components of facade on the building, and then getting to the solution. As you know, the engineering material or advanced design geometry is two terms which looks very or sounds very new, but we know that during the 10,000 or even more years of the heritage of architecture, they tried to find new materials, and also they tried to optimum the shapes. So as I know that you're all familiar with the process of design through evaluating the performance of the buildings, evaluating the different alternatives, how they behave, how they work, and then based on those results or outcome of the performance, shape the building and the form of the structure and the facade system. So it is clear, this basically cycle. So talking about the envelope specifically, we need to consider the envelope as a barrier between inside and outside. And so basically we should consider all the parameters, mainly here the physical parameters, like a solar radiation, what's happening outside the building. And also we should control how the temperature, moisture, and the lighting level is happening inside the building. But at the same time, we should consider the context. So basically these three aspects we should consider side by side and not neglecting one for the sake of the others. To predict the performance of the buildings and the behavior of the buildings, we need the simulation tools because they give us power to predict how they will react to the exterior environment, the environmental conditions. But yeah, to be honest, there is a big plus here, which I already neglected. Most of the parameters I show here, they are physical parameters, and there are so many social parameters we should consider as an architect. And to be honest, those are much harder to evaluate because they are more qualitative and not quantitative. So it's hard to find the magnitude and evaluate them. But keep in mind that there is a big plus here. Okay, talking about simulation tools and how we can evaluate the performance of the buildings, there was a big gap between these two aspects. The one I can say building simulation or building physics in general, or on the other hand, we have human subjects and how human body react to the environment, to the built environment. So these two topics has been studied for a long, long time, and they are really advanced for based on the researches over the decades. But also with parametric simulations nowadays and powerful computers, we can do a lot of this. We can simulate the human behavior or the physiology of the human subjects with considering individual person. And we can also run a lot of simulation with different types of the building. So this is thanks to the parametric simulation, which we can consider the individual properties. But there is a bridging gap which we need to consider. We need to put human into the building, not only simulating the building, but also we need to simulate the interaction of these two together. And this is thanks to the new approach, not really new, but an important approach, which is human-centric design. Okay, now about the simulation. There are plenty of softwares and programs available that we can use for simulating a dynamic facade, as you see in the list here, based on the types of the dynamic facade or adaptive facade, like electrochromic, thermochromic, photochromic, or fluid glass, which is running water inside the gap of the double glazing. We have some options like Energy Plus, ESPR, and Transit to simulate some of the parameters, mainly physical parameters in here. But still there is a plus because some of the tools are not really meant to simulate at least dynamic facade, or they are not meant to give us a good idea about how to control. So they are lacking in some aspects, and we can add some new developed tools, or you can tailor or customize some of the available open source tools to for your needs and develop them as you need in your simulation. So this is just one example that basically we work together with Sarit, and Sarit work a lot with how to basically calculate the solar radiation for the individual human body. We use a virtual mannequin inside the building, and we calculate the solar radiation on every individual body parts. So as you see, we have a tool called SoloCalc, and in addition to the FISCO, which is the thermophysiology, sensation, and comfort tool, we put and consider all these inputs as an environmental condition like air temperature, air velocity, relative humidity, and MRT, in addition to the solar load on the individual body parts to calculate how people feel the situation, what is their sensation about the building, and what is their overall comfort. So this kind of, for example, new developed tools can go beyond the already existing tools available for designing complex things like dynamic facade in the building. So we are talking about this plus. They are also not only in TU Kaiserslautern in our group, but in different groups and all around the world. There are many groups working on this additional part, basically. So thanks to the idea of human-centric design, now we can go beyond the normal simulation of buildings and separated like prediction of sensation in human bodies. Now we can define scenarios of how we really behave in daily base. For example, you work for 4 hours in a building which is different, and you walk through the yard and reach to your car, and after taking 25 minutes in your car, you reach your home, again indoor space, and you have a different situation in environmental condition, as well as like clothing, metabolic rate, and all these things together. So we can see the history of all these reactions interactions between the built environment and human body. And this is actually a very helpful tool to see the impact. And now we can try out and use this information to design the building and control our building in such a way that really help well-being into the space. So, but be careful, because you remember that somehow at the end the results are not what we expect. So we have these available tools, but maybe it will end up to some solutions like that. We should always be careful about this process. So this is the place I want to see that we have a kind of disorder in architecture, also in design, basically digital design, which it means that we make tons of design alternatives, and somehow we are lost which could be the good solution. As you say, for example, we have so many options and we really don't know or don't have any sense or a good picture what we are looking for. So we just generate so many alternatives which are not really helpful. So this is really a big problem, not only in my country, for example, back in Iran, but I see that in Europe also a lot. The thing is, let's go back to the idea of form follows performance. Now we consider the human inside the body and we try to understand the interaction of these two together. But what we generate from the simulation tools, or what we gather from our instruments or sensors or all devices implemented into the buildings, these are all data. We can subdivide them or categorize them into objective data, mainly physical data that you can feel, or you can put it into the numbers. But we also have some subjective data coming from the occupants, getting from some voting app or getting some feedback from them. And also we can somehow understand the behavior of people. So we are dealing basically with data, and this data is making our form nowadays. And talking about data, now we are in the age of this new era, which we always think about something large and huge. The data are really big, so we can easily get lost into this nonsense abstract values, and we really need to distinguish what is falsified, what is the fake data or fake news, and how to check the validity of the data. It's a big challenge now. So I believe that the architects too, they need to go through the process of data analyzing and doing data mining, getting all the data from the servers or their simulation results, which are huge now because of thanks to the parametric simulations, and visualize them to understand the validity of the data.